Binomial theorem. So first of all, starting with the binomial theorem, I want to discuss with you the factorials. Yeah. So what are factorial? See, if I write n factorial, so this is this thing can be written as n minus 1, n minus 2, n minus 3 and so on till you get 3, 2, 1. So these are all actually in multiplication. Okay. So now if I write 7 factorial, now 7 factorial, how to write 7 factorial? 7 factorial is 7, 6, 5, 4, 3, 2, 1. That means 7 times 6 times 5 times 4 times 3 times 2 times 1, that is 7 factorial. And in the combination, like we have learned NCR. NCR, C stands for this combination. So this is actually n factorial upon r factorial into n minus r factorial. For example, we take 7 C 4. So this thing can be written as 7 factorial by 4 factorial, 7 minus 4 factorial. So this is 7 factorial by 4 factorial into 3 factorial. And to further solve it, this is 7 times 6 times 5 times 4, 3, 2, 1 and this is 4, 3, 2, 1, this is 3, 2, 1. So 2 will get cancelled by 2, 3 by 3, 4 by 4, this goes 2 times, 2 by 2. So we have 7 5s are 35. And the last point is that you should know 0 factorial, we take 0 factorial as 1. Okay. So now binomial theorem. Now the expression of the form x plus y, this x plus y, this is called binomial. Now suppose by direct multiplication we may expand, like if I do x plus y whole square. So we may write like x plus y times x plus y. Similarly x plus y whole cube, or we can directly expand, we know the formula of x plus y whole square, x plus y whole cube, etc. Now see, the ancient mathematician knew about the expansion of x plus y to the power n for n lies between 0 to 7, but this is just a history part. Around like whatever in 1660, I think around 1600, the B. Pascal introduced the Pascal's triangle for the expression of x plus y to the power n. So basically the Pascal triangle gives the coefficient of various terms in the binomial expansion. For example, if you see this, see x plus y to the power 0 is 1, x plus y to the power 1 is x plus y, x plus y to the power square, we know this, x square plus 2x square plus y square, x plus y whole cube is x cube plus 3x square y plus 3xy square plus y cube. Now if you see the coefficient, this has coefficient 1, x plus y to the power 1 has coefficient 1, 1. Similarly, x plus y whole square has the coefficient 1, 2, 1. X plus y whole cube has the coefficient of 1, 3, 3 and 1. Now that is what the Pascal triangle shows, the coefficient of various terms in a binomial expansion. Now see, this is a Pascal's triangle. Now index means to the power, like x plus y to the power, if it is 0, 1, 2, 3 and 4. So if it is 0, the coefficient is 1. For 1 it is 1, 1. For 2, see, we write the first term as 1, last term as 1 and the middle term is obtained by adding these two, 1 plus 1, 2. Similarly 3 is this, first term and the last term is 1, 1. This term is obtained by adding 1 plus 2, 3, 2 plus 1, 3, 1. So coefficient is 1, 3, 3, 1. As you can see, x plus y whole cube 1, 3, 3, 1. To the power 4, the first and the last term is 1 only, This is 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and this last term is 4. So, in a Pascal's triangle, we have seen that each row starts with 1 and the end with 1. Now, second point, each coefficient except the first and the last in a row is the sum of two coefficients in the preceding row. Now, sorry, one just before it and the one just after it. Like 4, this is obtained by 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4. Okay. So, now the expansion of binomial term for like x, you can take x plus y to the power n. Now, this is written as n c0 x to the power n plus n c1 x to the power n minus 1 y plus n c2 x to the power n minus 2 y square and so on. If you go on like this, you get n c n minus 1 x y to the power n minus 1, and the last term will be n c n y to the power n. So, this is for the expansion of in a binomial theorem, x plus y to the power n, or you can write the general term, or you can write this as x plus y to the power n. This is summation. Summation stands for the sum r equals to 0 to n. That means we start from r 0 and we will go till n terms. So, this is n c r into x to the power n minus r into y to the power r. So, this will be the general term. Now, there are some observations also in a binomial theorem. Now, in a binomial theorem, just a second. Now, these are the observations in the binomial theorem, or now in the binomial expansion. The first observation is, if you take x plus y to the power n terms. Now, if suppose it is x plus y to the power n terms, so this has total n plus 1 terms. So, number of terms is n plus 1 terms, and also like in combination NCR as we have discussed just now. So, that can be written as n c n minus r. So, this means the coefficient of the terms equidistant from the beginning and the end in a binomial expansion that are equal. So, this is NCR, that is equal to n c n minus r. So, if you see the coefficient of terms equidistant from the beginning and the end, they will be equal. Now, the general term in the expansion of this is x plus, this is actually n, x plus y to the power n. Now, general term in the expansion of x plus y to the power n. Now, we write general term as r plus 1th term. So, that is t r plus 1, this is t r plus 1, which is equals to n c r x to the power n minus r y r, n c r x to the power n minus r y r. Okay. Now, the middle term in the expansion of x plus y to the power n. See, it is simple. If n to the power which is n, if n is even, then the middle term is n by 2 plus 1th term. Middle term is this n by 2 plus 1th term, that will be the middle term. Now, when n is odd, when n is odd, the middle term will be n plus 1 by 2 2th term and n plus 1 by 2 plus 1th term, or you can directly do if n is odd. Suppose n equals 7. Okay. So, what you do, 7 plus 1 by 2, the 8 by 2, which is the 4th, and the next term means 4th and the 5th term if n is odd. Now, pth term, now if you have to find the pth term from the end in x plus y to the power n. So, just simply use this formula n minus p plus 2th term. So, that will be the term from the beginning. So it's obvious because we are doing the formula from the beginning. So if pth term from the end, let's just do n minus p plus 2th term from the beginning. Now, so now instead of x plus y to the power n, now we have 1 plus x to the power n. Now we have 1 plus x to the power n. So this is nc0 plus n c1x plus n c2x square plus and so on n cn x to the power cn x to the power n. Okay, and the nth term is tr plus 1, that will be ncr, this is x to the power r. Now suppose instead of plus we have minus. Now x minus y to the power n. So this is nc0 minus, this is actually minus nc1 x to the power n minus 1 y plus nc2 x to the power n minus 2 y square and so on. So we will see that, see, minus sign is with y. So an alternate, like when it is y to the power 1, this will be negative. When it is 2, since this is minus y, so minus y square, that will give you positive. So basically you get minus sign in alternate position, like in this, then on the third one, then on the fifth one and so on. The general term will be of x minus y to the power n. So this is summation, not the general term, just to represent. So this is r equal to 0 n, this is minus 1 to the power n, ncr x to the power n minus r yr. Now the general term. So this is tr plus 1, it's minus 1 to the power r, see, minus 1 to the power r. So it depends to the power r, like y, what is y to the power? If y has odd power, negative sign, y has even power, positive sign. So this is ncr x to the power n minus r yr. Now when this is minus, so 1 minus x to the power n, so nc0, then negative, minus nc1x plus, then positive, nc2x square minus, this is to the power 3, so negative, and so on, minus 1 to the power n, ncn x to the power n. 1 minus x to the power n, this is summation n r equals to 0, just to represent, minus 1 to the power r, ncr xr. Also 1 minus x to the power n implies tr plus 1, so minus 1 to the power r, ncr xr. This is the nth term. So this will be the nth term. So that's what all we have in the theory. Now we will be discussing and solving some examples. So now our first example is expand 2x minus 3 by y to the power 5 by using the binomial theorem. Now you can see minus, as again looking to the formula. Now this is the formula, x minus y to the power n is nc0 minus x minus y to the power n is nc0, sorry, this is x to the power n, I am really sorry for this, nc0 x to the power n, and this is nc1 x to the power n minus 1 y and so on. So see, that means where y, we get alternate negative sign, where the power of y is odd, you get the negative sign, like it if the power is 1, negative sign, power is 3, negative sign, power is 5, negative sign. So taking this term as the x and this as y, and now also I am really sorry for this, this is actually nc0 x to the power n. So I am writing it again, this is nc0 x to the power n minus nc1 x to the power n minus 1 y and so on. Okay, so now let's start. So this is our expansion. So first is we write 5c0, now 2x to the power 5, this is our first term, then minus 5c1 2x to the power 4, 2x to the power 4, this is 3 by y. Now this has power 1, so negative sign. So negative sign, plus 5c2, 2x, now 3. The power of this will reduce, but the power of that y will increase. Now this has 3 by y whole square. Now minus this is 5c3 2x whole square, and this is 3 by y to the power 3, and this is 5c4 2x, this is 3 by y to the power 4, and then minus 5c5, this term will be eliminated because 2x to the power 0, 5c5, this is 3y to the power 5. Now we have to solve. See, 5c0 is actually 1, 2x to the power 2 to the power 5 is 35, so this is 32. This is 32 x to the power 5. Now 5c1, 5c1 is actually 5, and this is 2 to the power 4. So 2 to the power 4 is 16, and 16. So this is, we can write, for being weird I can write 5 times 16 x to the power 4, this is x to the power 4 into 3 by y plus. Now what is 5c2? 5c2 is 10. You can solve 5c2, as I told you, this is 5 factorial by 2 factorial upon 5 minus 2 factorial. So if you solve 5c2, you get 10. So this is 10 into, now what is 2x? This is 8x cube into, this is 9 by y square. Okay. Minus, again 5c3 is 10 only, into, this is 4x square, 4x square, and this is 27 by y cube plus 5c4. Now what is 5c4? 5c4 is 5, this is 2x, this is now 3 to the power 4 is 81 upon, this is y to the power 4 minus 5c5 is 1, and 3 to the power 5, 3 to the power 5 is 243, 243 upon y to the power 5. So here you get. Now solving it like multiplying 5 into 16 into 3, 10 into 8 into 9, this is minus, this is plus, minus, plus, and in like on regular solving, the answer is 32 x to the power 5 minus, this is 240 x to the power 4 y plus, then it's 720 x cube y square, this one, then minus, this is 1080 x square by y cube, okay, and this is plus, this thing is 810 x by y to the power 4, and this is minus 243 y to the power 5. So here is the expansion, here is the final expansion of this. Next. Okay, expand using binomial theorem. This is 1 minus x plus x square to the power 4. This is 1 minus x plus x square to the power 4. So here we have to actually group it. So we can group it like this. You can write 1 minus x plus x square to the power 4. Okay, now this becomes x, and this is what? This is y. So now here we start our expansion. So first of all is 4 c0, this is 1 minus x to the power 4, okay, because this has plus sign, so every identity will be plus only. And then again plus 4 c1, 1 minus x cube, and this is x square. This is already x square, so x square to the power 1 plus you have 4c2, this is 1 minus x whole square, but now this will be x square whole square, okay, plus 4c3, this will be 1 minus x square cube, then plus 4c4, this becomes 0, only x square to the power 4 is left. Now 4c0, actually 4c0 is 1. So this will be, this expression will be 1 minus x to the power 4 plus, now 4c1. Now what is 4c1? 4c1 is 4. So this is 4 x square, 1 minus x whole cube plus, what is 4c2? 4c2 is 6, and this is x squared square. X squared square is x to the power 4, and this is 1 minus x whole square. 4c3 is 4, and this is x to the power 6. So 4 x to the power 6, 1 minus x plus, this is actually 4c4 is 1. So x square to the power 4, you can write x to the power 8. Now, now you have to solve, means you have to expand 1 minus x to the power 4. Now see, if you remember this formula, 1 minus x to the power n, this is nc0 minus nc1x. So means if the power of x is odd number, you get negative sign, plus nc2x square, like minus nc3x cube and so on. So you have to apply this formula in this 1 minus x to the power 4. So see, on applying the formula on this thing, so you will get, see, 4c0 minus 4c1x plus 4c2x square minus 4c3x cube plus 4c4 x to the power 4. Okay. So this is expansion of this. Now plus this thing 4x square. Now again start brackets 3c0, because this is 3, 1 minus x to the power 3 minus 3c1x plus 3c2x square minus 3c3 x3 or x to the power 3. Okay. Now plus this term 6x to the power 4. Now just expand, we know that this is 1 minus 2x plus x square. We know this because this is what? This is a minus b whole square. Whole square plus 4 to the power 4 x to the power 6, 1 minus x plus x to the power 8. Okay. Now we know that what is 4c0. Now write the values. This is 1. You think it's 1 minus 4c1 is 4. This is 4x. This is 4c2 is 6, 6x square. 4c3 is 4. This is minus 4x cube plus x to the power 4. Okay. Now plus this thing 4x square. Now we know that 3c0, this is 1 minus, this is 3x, 3c2 is again 3 plus 3x square, this is 1 minus x cube, 3c3 is 1. Okay. Plus 6x to the power 4, this is 1 minus 2x plus x square plus 4 x to the power 6, 1 minus x plus x to the power 8. Okay. Now, what we'll do is that we will start opening the bracket. So now this is all multiplied with 4. This is all 4x square. This is to be multiplied with 6x to the power 4. This is 4x to the power 6. This. So this will remain same, 1 minus 4x plus 6x square minus 4x cube plus x to the power 4 plus in bracket. Now this will be 4x square minus 12x cube, because we are multiplying 4x square with these terms. Okay. Plus 12 x to the power 4 minus 4x to the power 5 plus, now this thing, this is to be multiplied with each term. So 6x to the power 4 minus 12x to the power 5 plus 6x to the power 6 plus 4x to the power 6 minus 4x to the power 7 plus x to the power 8. So this is our expression. Now opening the bracket, because you see this is all addition. So just adding and subtracting the like terms. If you want to rearrange it, so on rearranging, writing the highest power first. So this will be x to the power 8 minus 4x to the power 7 plus 10x to the power 6 minus 16x to the power 5 plus 19x to the power 4 minus 16x cube plus 10x square minus 4x plus 1. So this is how the expansion is done. Now, next example, find the sixth term in the expansion of 4x by 5 minus 5 by 2x to the power, this is 9. Now, as you know, again looking at this formula, x minus y to the power n. See, the general term is minus 1 to the power r, NCR, x n minus r, yr. So this is the general term. So now, using the general term, now see, they are saying the sixth term, sixth term. So see, what we do is that we write r plus 1th term as t r plus 1. So this is equals to, since this is minus, so minus 1 to the power r, this is n c r, and this is x to the power n minus r, y r. Okay, so this is x and this one is y. So in the expansion of this, now what we do, we write t6 as t 5 plus 1. So this is minus 1 to the power 5. N is how much? N is 9. So 9 c. R is how much? R is 5. 9 c 5. And x is how much? 4x by 5 to the power 9 minus 5, and this is 5 by 2x to the power 5. Okay. So minus 1 to the power 5 is basically minus 1 only. So this is minus 1. Now 9c5, we can write 9c5 as 9c4 also, because we have done that formula, like NCR is equals to NCN minus R and Cn minus R. So you can write this as 9 c4, and this is to the power 4 now, 4x by 5 to the power 4, and this is 5 by 2x to the power 5. Now we have to solve 9c4, and this will be our sixth expression only. So 9c4 is basically 9 factorial. Let's solve it over here. So 9c4 will be 9 factorial upon 4 factorial into 9 minus 4, 5 factorial. So, this is actually 9 factorial is how much? 9 into 8 into 7 into 6 into, we can write this as 5 factorial. This 4 factorial, 4, 3, 2, 1 into 5 factorial, so these two will get cancelled. So, you get this 9 into 8, really sorry. 9c4 is 9 factorial, 4 factorial by 5 factorial. So, 9 factorial is 9, 8, 7, 6, you can write this as 5 factorial, and this is 4, 3, 2, 1, 5 factorial and 5 factorial will get cancelled. So, this is the value. So, now you can write this as minus, so 9, 8, 7, 6, 9 into 8 into 7 into 6 upon 4 into 3 into 2 into 1 into, now see 4 को you can write like at 4 you can write 2 to the power 2 to the power 4, this is 2 to the power 8 x to the power 4 upon 5 to the power 4 into, this is 5 to the power 5 upon 2 to the power 5 x to the power 5. Okay. So, you can see this actually will become 2 cube because this is 2 to the power 8, this is 2 to the power 5 and this will become 5 and this will become x to the power minus 1. Okay. So, basically if you solve these numbers, this is 2. So, this is 2 to the power 3, this is actually 8 and this is 5. So, 8 into 5, 40, then this upon this, you solve it basically. So, you will get minus 5040 into x to the power minus 1, or you can do this minus 5040 by x. So, this is our sixth term in the expansion, to find the sixth term. So, basically what we have done is that to find the sixth term, what we have taken? We have taken the rth term, the journal term. So, again the journal term is given by this formula x for x minus y to the power n minus 1 to the power r NCR x to the power n minus r y to the power r and we take r plus 1th term. So, this was the sixth term, that is why this T6 we write this as T5 plus 1, that is r plus 1th term. So, the value of r is 5 over here. Okay. Next example. So, now here is the next example. Find the fifth term from the end of the expansion of. So, we have done like fifth term from the end, that is pth term from the end in this is actually n minus p plus 2th term from the beginning. So, first of all we have to find which term is from the beginning. So, this is n minus p plus 2th term from beginning. Okay. Now, this term from the beginning, see n minus p plus 2. So, what is this? This is the sixth term. So, you have to find the sixth term from the beginning, is same as this. Now, again T6, you can write T6 as T5 plus 1, T6 can be written as T5 plus 1. Now, again this is of minus. So, this is of minus, we have to use again this thing, x minus y to the power n is minus 1 to the power r NCR x to the power n minus r y r. Okay. So, using the formula, so this will be minus 1. Now, what is r? R is 5 because T6 they are saying the sixth term now. So, this is r is 5, this is minus 1 to the power 5 into what is n? N is 9, 9 c 5, then this is x cube by 2 to the power 9 minus 5 and this is 2 by x square to the power 5, which is r. So, basically this is 1 only. Again 9 c 5 will give you the same thing as I have discussed in the previous question, or you can write this as 9 c 4, you solve it. This will be x cube by 2 to the power 4 and this will be 2 by x squared to the power 5. Okay. Now, so we know the value of it now, 9c4, this is 9 into 8 into 7 into 6 upon 4 into 3 into 2 into 1. Okay. Now, this is what? X to the power 12 by 2 to the power 4. This is 2 to the power 5 upon x to the power 10. So, basically 2 to the power 4, 1, this will be cancelled by 2 to the power 5. So, when you solve all this, your answer is minus 252 x to the power 2. So, this is the fifth term from the end of the expansion of this term. Now, find the middle term in the expansion of 3x minus x cube by 6 to the power 7. Now, we can see what is n. N is 7 over here, which is an odd number. So, as we have already discussed, an odd number, what you do is that you do 7 plus 1 by 2, which is 4, and the next term, fourth and the fifth term. So, there are two middle terms actually. So, basically you have to find the fourth term and the fifth term. So, now starting with T4. So, T4 can be written as T3 plus 1, T3 plus 1. So, which is actually TR plus 1. What is R? R is 3 over here. So, this is the expression. So, this is minus 1 to the power 3, and this is n is 7, 7 C3. So, this is 3x to the power 7 minus 3, and this is x cube by 6 to the power 3. So, this is our fourth term. Now, the fourth term we know that this is minus 1. Now, 7c3, if you do this is 35, 7c3, this is to the power 4. So, this is 81, 3 to the power 4 is 81 into x to the power 4. This is cube into this is x to the power 9, and 6 to the power 3 is 216. So, this is the fourth term. If you solve it, you will get minus 105 x to the power 13 by 8. Now, the fifth term, T5, this is equals to T4 plus 1. Now, T4 plus 1 is minus 1 to the power 4. So, again same formula, 7c4, 3x to the power 7 minus 4, and this is x cube by 6 to the power 4. Now, minus 1 to the power 4 is 1, 7c4 is 35, this is cube. So, this is 27 x cube, this is to the power 3, so 27 x cube, this is x to the power 12, and you have to do x6 to the power 4, which is 1296. So, you have to solve this. On solving this, what you will get is 35 x to the power 15 by 48. So, this is our fourth term and this is our fifth term. Okay. Moving on to the next example. Find the coefficient of x to the power 32, x to the power minus 17 in the expansion of x to the power 4 minus 1 by x cube to the power 15. Now, see, we have to find the coefficient x to the power 32. So, first of all, what we will do, we will